Okay, we learned how to describe the function from the snowfall graph. If you remember, that was from the previous sections. And now in here, we're going to say how to describe a function from the graph. Okay, or you can say that more on the functions and their graphs. How to describe. Mathematically, if you will want to describe a function from its graph, okay, you're not going to say it's a nice graph, it's a beautiful function. No, you have to say something more. Okay, so you could say either it's increasing, I will explain later, and what does that mean. Okay, it's an increasing function or decreasing function, it's going down, right? Or constant function, constant. Okay, so let me give you a graph so you can tell what I'm saying. And of course, I always do this. I always do 0, 1, 1, and y and x. That gives me a complete x-y coordinate system or coordinate plane. Okay, now let me show you a graph. This is a function. It's a function because if I use the vertical line test, see, I go from left to right. I hold my pen vertically, and then I only touch the function no more than 2 points at a time. So that is a function. And here, look at this part. This part, you go, if your point comes from here to here, their x value or the x-axis starting from here to here, isn't it? So that's going up, because from left to right, that's going up. So when x goes up, what happened to its y? Here is the corresponding y coordinate, and here is the corresponding y coordinate at the ending point. Here's the starting point. So the y goes down. When x goes up, which means you're moving from left to right, y goes down. You can see the graph, it comes lower, right? So that goes down. So that means from here to here, it's a decreasing. Now this function, can you tell me where this function is decreasing? Well, the function is decreasing when x is less than 0, so it goes down when x touches 0, and then from 0 to somewhere here, let's say that would be 1, 2, 3, okay, so that's 4. And then so from 4 and above, when x goes from 4 and above, y value goes down. So this function is increasing between 0 and 4, but it's decreasing from negative infinity to 0 and from 4 to positive infinity. That's how you describe a function just by looking at this graph. Just go from left to right and to see whether it's going down or up or down. Decreasing, increasing, decreasing. All right. Now, what about this is f of x. So we're going to say f of x is increasing. F of x is increasing when x is increasing from here, from 0 to 4, right? This is an interval notation, okay? This is not a point coordinate. And f of x is decreasing when x is in, okay, that's from negative infinity to 0, and the other way to show and is this little symbol, looks like a U, okay, so that's called and, from 2 to positive infinity. Okay, you might notice here I always use the parenthesis instead of a bracket, because that's okay, you can just do it. But whenever you see negative or positive infinity, you always use a parenthesis, okay? All right, so we know how to describe it. And let me give you another one. Okay, What about for this function? Not enough space. X and y. Here's a 0 and a 1 and a 1. What about this function? That is also a function because it will pass my vertical line test. It's a function. And this function is f of x is always 2.3. What does that mean is whatever x value as your input, remember the function that we considered that as a magic box? You're putting an x value. In this case, x can be anything from negative infinity to positive infinity, all or any real number. Then the y comes out is always 2.3. So you get this flat line, and that is a constant function. All right, so the reason it's a constant means the output is a constant, so f of x is a constant. In this example that I give you, the whole function is a constant function, but sometimes if you have like a graph, it goes up or down, and in some interval it's a flat, then you can say this function is a constant function when x is in that interval. All right. All right, now one more thing after we know increasing, decreasing, and a constant, we are going to learn something called relative minimum or relative maximum. Okay. This is the important word, relative, because this function, it doesn't really have, for overall, I couldn't see the minimum or maximum for this whole function because I don't really see what's going on this side and then what is going on the other side. However, I can see this part. Okay, did you see the function go from decreasing and then when it touches here, it go up? So this point, I'm going to say this function will reach its relative minimum when x equals 0. Relative minimum. We don't care about this little small neighborhood. And this is my relative maximum. So f of x will reach its relative maximum when x equals 4. So that's the general idea, okay? So that's, see, that's another concept. All right, now, after this increasing, decreasing constant, after we learn the relative minimum, relative maximum, the next thing is a symmetric. Symmetric, there are different type of a symmetric. Okay, let me just write this first. Symmetric. You know, symmetric sounds like a mirror image, right? Okay, so there are several ways. One is the symmetric with respect to the y-axis. That means like a y-axis like the mirror. Or we can say with respect to the x-axis. That's how do you describe a graph, right? Or you can say with respect to the origin. Okay, so I'm gonna show you more graphs so you can see. Okay. Now, what is a symmetric with respect to the y-axis? So you're gonna think your y-axis is your mirror. That's your y-axis. That's a mirror. Okay, so if you have a graph, look like this. It's a beautiful graph on this side, and on the right side it goes like. Okay, so this function is symmetric with respect to y-axis. And see, it will also, it's a function, right? It will pass this vertical line test. It's a function. So this one is symmetric with respect to the y-axis. Now, what about the symmetric to the x-axis? Okay, did you notice I always do that, huh? All right, so if you have a graph that looks like this, and down here you have, it's like a mirror, your x-axis looks like a mirror, then this graph is called a symmetric with respect to the x-axis. Is this a function? It's not, because if you use the vertical line test, it will fail. So it's not a function. Okay, now the last one, symmetric. The last one is a symmetric with respect to the origin. So you have this graph. Here's a 0, 0, 1, and a 1, and a y. Okay, I got this xy coordinate system. So if you have a graph look like this, and on the other side, it was like you're rotating this 180 degree, right? So you're rotating it. It goes like that. Okay, so this is called a symmetric along or symmetric with respect to the origin. So for any point you have on this graph, on this part of the graph, see, with respect to here. Do you see that? So this, you don't have really a mirror, but you have like a single point. So for any point you have on the graph at this side, so you can have another point on the graph. All right, so this is called symmetric with respect to the origin. All right, now we don't worry about this. We don't worry about this. We don't worry about with respect to symmetric with respect to the x-axis because it's not function. However, this is a function and this is a function. All right, now let me look at this. Okay, we take a quick look at this. Because this is like a mirror. All right, so if I choose an x value and I get the corresponding y, okay, so I have this point. At the same time, because we think y-axis is the mirror, I will have this point, right? All right, so for this one, if this is x or y, what about this one? This should be negative x, y. You agree? Because the x intercepts, or we say the x intercept for these 2 points is just positive and negative, right? They're symmetric. However, their y value is exactly the same. Therefore, what we can tell is f of x, important here, okay, equals f of negative x. Makes sense? F of x, the function of x, you're putting x, you come out of y, or if you're putting negative x, you come out with the same y. And we call this, there's a beautiful name for that. Okay, it's called an even function. Every time when we talk about an even function, this is what I mean. Okay, it also means its graph is going to be symmetric with respect to the y-axis. All right, now what about this one? What about this one? See, if this point is x or y, what would be the coordinate of this point? See, here's an x and here's a y. I just didn't give you the value, okay? If you like, you can find the value. And this is here. So if you get an x or y on the graph, you have a negative x and a negative y on the graph too, isn't it? Because the x from positive to negative and a y from positive to negative. So this is f x y and this is negative xy. So which means f of negative x equals negative f of x. So your input is opposite. One is x, the other one is negative x, and your output will also have the different sign, which is different than the even function. Even function is you're putting positive x and negative x to get the same y. But for odd function, see, that's another beautiful name, right? Odd function. You're putting different sign of x and a negative x, your output will be also have a different sign. All right. So that's even odd function. Now we're going to say, well, I'm going to ask you to check whether it's an even function or not, or odd function. So the first one, y equals x squared. What do you think? Okay, you're going to put in x and a negative x to see whether they're equal, or they have opposite sign, or they have totally no relationship. All right, so x squared, or we call that f of x equals x squared. Okay, and f of negative x, that would here, which is f of x is x squared. So negative x, remember f of something equals something squared. So f of negative x, if you remember that I put like f of whatever here would be whatever thing square, right? So f of negative x will be negative x squared, which is negative x times negative x. Negative negative becomes a positive, so you have x squared. So now you see you're putting x and a negative x as the input. What do you think about the output? They're exactly the same. Therefore, f of x is an even function. Okay, sounds good? Yeah. All right, now let me ask you another one. Let me ask you, what about y equals x cubed minus x? It's a hard one, okay? So which is f of x, or f of a box, let me just put a box, equals that box cube minus the box. Okay, so let's see. If I just put in x, which is just the x cubed minus x, what about f of negative x? Okay, think about it, here is a negative x, negative x, negative x. So that would be negative x cubed minus negative x. Agree? And the negative x cubed, see, negative x, negative x, negative x, multiply by itself 3 times, so negative, 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 positive, plus one more negative. Okay, so that would be negative and x cubed. And here, negative, negative becomes a plus x. What is the relationship between these two? Just different sign, right? So that is negative of f of x. So therefore, this one is an odd function. You remember this? Okay. This is how you, starting from the function, plug in x, plug in negative x, find the output, and to see the relationship, and then you can tell whether it's an even function or an odd function. The other way to do that is just by looking at the graph. Okay, if you have the graph look like this, whew, that's an even function. If I have a graph look like this, then that's an odd function. Okay, and a couple of more concepts. The other one is called piecewise function. Piecewise function. I give you one example. I tell you f of x equals x plus 2 when, or if, it's the same thing, x is less than or equal to 1, and it's a 4 if x is greater than 1. So x could be any number, it could be any real number, right? It could be less than or equal to 1, and it could be greater than 1. So when you graph the function, it looks like this. Here's x, here's a y, here's a 0, and 1, 2, and 3, and 4, and here's 1, 2, 3, 4. Okay, and when x is less than equal to 1, and we can make a little chart. X is less than or equal to 1, so I can put a -1, 0, and a +1. I can do that. And then to find the y is x plus 2, so I just use number plus 2. -1 plus 2 is a +1, and a 0 plus 2 is 2, and a 1 plus 2 is a 3. So I get this point, and this point, right? I get this point. So x less than or equal to 1, including 1. So I'm going to connect that. That's a straight line, and I will have a solid point here. Okay? Well, this is what happened when x is less than 1. What about x is greater than 1? When x is greater than 1 means from all the way from 1 to the right, and y has a constant value, which is a 4. It's a constant function. So starting from here, we get a flat line. And what should you put here? Because here says x greater than 1, x cannot be 1. Therefore, I'm going to put a circle. I'm sorry, it looks like a 40, but it's not. Okay, so here is a circle. All right, now this is a graph. Is this a function? If you use the vertical line test to see whether your pen will only touch 0 or none point, you see? The most important thing is here, right? When x equals 1, there's only one outcome, or there's one possible point here, which is at 3. But from 1 and above, from above 1, then it becomes a 4. So it is a function. So sometimes you see this, which means in different interval in your domain, you have a different way to express the function. This is called a piecewise function. All right, now the last part is the last thing I ask you to find out is this. Okay. If you have a graph, I don't really know, I don't really know the function right now. Okay, so if you have this point, and then you have another point. Okay, so let's see. This is x and y, okay? Which means here is x, here is y. All right, now I will move to the right by little h. Okay, h is a value, so this point will be x plus h, right? And what about the y-intercept of this point? That will be f of x plus h, isn't it? All right, now I want h cannot be 0. H has to be something. All right, now I will ask you to find the slope of this little segment line. It should be a straight line. Okay, I didn't do a very good job, but it should be a straight. Okay, I ask you, what is f of x plus h minus f of x, which is the difference between this and this, divided by x plus h minus x, the difference between this and this. So that's from here to here, that's a difference, and from here to here, from here to here, and that's a difference. So x plus h minus x, that x get cancelled, and we have an expression of this. And there's a special name for this when h is not a 0. This is called difference quotient of the function. Okay, this concept is fairly important, especially in the future if you would like to study calculus. then you need to do this. So can we do that? Okay, I give you a function. Sorry, I was disconnected. I give you a function, and then we're going to find out this the difference quotient of this function. Okay, so the function I give you is f of x equals negative 2x squared plus x plus 5. This is very challenging, okay, because it's involved in a lot of things that I suppose you know already. So I'm asking you, what is this? F of x plus h minus f of x over h. Okay, I'm asking you to this, and then you get to simplify that. All right, now first of all, when I give you f of x equals this guy, can you find what is f of x plus h? Remember the function part, right? Definition of the function, or the main idea of this function, is f of the independent variable or the input equals this, and you're going to put whatever x here, put in here. And now we don't have x, and we have x plus h. So let me just do the first part, which is negative 2 times x plus h squared plus x plus h plus 5 bracket. Okay, so this, the whole thing in the bracket, is the first part. And the second part, f of x, which is negative 2x squared plus x plus 5. Then the whole thing divided by h. All right, now we're going to spend some time to work on this because we have x plus h squared. Let me just use a little space at the right. And if you remember the x plus h squared, if you know the formula, that is x squared plus 2hx plus h squared. Or if you use the FOIL method, x plus h times x plus h, FOIL, first times the first, outer times outer, inner times inner, last times last. So that will be first times the first, x squared, outer, which is h and x, h times x, and inside is another h times x, and then the last term is h squared. So if you combine the like terms, you get this part. So that should be the same thing, okay? So then I'm going to write here, still in the bracket, because I don't want to skip too many steps. So I get a negative 2, and inside the parentheses, because I already did the square, so I just put x squared plus 2hx plus h squared. Okay, and then I'm going to go ahead and plus, I can just open this parenthesis because there's really nothing I could do. So x plus h plus 5. Okay, so that's the first part. And then I go minus this. But when I do minus the whole bracket, so I just distribute the negative sign inside, basically, which means I'm going to change the sign for every single term by eliminating that bracket. Okay, and then divided by h. I still remember that. Phew! So I keep this aside. Okay, that's my side work. And then I'm going to distribute this negative 2 into each term. At the same time, I don't really need this bracket anymore, so I have negative 2x squared, and then negative 2 times positive 2, I get a negative 4hx, negative 2 again, negative 2h squared. So be very, very careful, okay? Then plus x plus h plus 5 plus 2x squared minus x minus 5. There's so many terms, and it's so easy to make a mistake. So I'm going to use different color of my marker to show what did I do next. There are a lot of things get canceled. See, like a negative 2x squared, positive 2x squared. See, I cross out this. You can see, and then I have here is negative x, and here's a positive x, and then that is gone. You agree? And then I have 5, and a negative 5. So everything in this color circle will be gone. Okay, because positive, negative cancel. And there is no more thing I can drop. So I will have negative 4hx minus 2h squared plus h over h. Okay, so I can factor h out from the numerator because in the future I'm going to drop out with the denominator, right? So if I get h out, I get a negative 4x, I get a negative 2h, and I get a plus 1. Okay, then I will cross out this h from numerator and the denominator, so my answer is negative 4x minus 2h plus 1. That's my answer. Alright, so that's it. It's pretty hard, this part, isn't it? Yeah, but I think it's fun.